Okay, so the first part of the do now, I'm asking you just to simplify. And the first one, we have 1/9 plus 7/9. In order to be able to add fractions, what must we have the same? The denominator. We must have a common denominator. Do we have this common denominator? Yes. So the rule tells us we're going to keep our denominator the same and add the numerators. So 1/9 plus 7/9 is 8/9. What happens when the denominators are not the same? What happens when the denominators are not the same? What do we have to do there? Good. We need to create a common denominator, right? Which is the least common multiple. So we need our common denominator. And what's a common denominator for 4 and 6? 12. So we create this common denominator through multiplication. So for the first one, I'm going to multiply top and bottom by 3. And that's going to give us 9/12. For the second one, we're going to multiply the denominator and numerator by 2. So that's going to give us 10/12. And then we add 9/12 plus 10/12 is 19/12. Can I simplify 19 over 12? No, I cannot reduce that fraction. I know in the middle school they love mixed numbers and decimals. We love improper fractions. The only time we change it to a decimal is if it's going to make it easier for us. For example, if it was a point that we were going to plot on a graph, plotting a decimal is easier than plotting an improper fraction, right? Or if we, I don't know, any other scenario where it would make our lives easier, that's the only time we would change it. Any other scenario, we make sure it's reduced and we leave it improper. All right, the directions are still to simplify. And here we're going to have x over 4 plus 5 over 6. Again, we're adding fractions. In order to add fractions, we need to create a common denominator. So our common denominator is 12 once again. So we multiply this by 3, and we multiply this by 2. So now we're going to get 3x plus 3x over 12 plus 10 over 12. Now we just go across and we add 3x plus 10 all over 12. Is there any GCF I can pull out of that numerator that can simplify with the denominator? No, there's not a GCF we could pull out in the numerator at all. So we stop here. Why did I give you this problem? I gave you this problem, and the very next problem I made it very similar but so different. X over 4 plus 5 over 6 equals 10. All right, this is going to, because I'm bringing it here like Algebra 1 style, but this is what's going to trip you up the most, the conceptual part of this, because you're just going to get in your own heads and not think about it. What's the difference between number 3 and number 4? What's the difference between number 3 and number 4? Sion?
2 expressions.
Number 3 is an expression that we are doing what?
You just add.
Simplifying, exactly. We're just adding. What's number 4?
You're solving for x.
Yeah, what do we call that when there's an equal sign? An equation. So Sion nailed it. Number 3 is just an expression that we're simplifying. Number 4 is an equation that we're solving for. Right? When we're simplifying, you have no choice but to create a common denominator. There's no other way about it. But when we're solving an equation, once we have an equal sign and once we have a number after the equal sign, actually you are not wanting to create a common denominator. What is the best method for solving an equation with denominators? Yeah, eliminating the denominator. Are we allowed to eliminate the denominator if we're simplifying? No. But once we add an equal sign and a number after it, that's what we want to do. We want to eliminate the denominator. How do we eliminate the denominator? You still look at the two denominators. You ask yourself, what would be the common denominator for 4 and 6? What would be the common denominator would be 12. But instead of creating that common denominator, you go through and you multiply each part by that common denominator, even on the other side of the equal sign. Even if there were whole numbers there, every single thing gets multiplied by what would be that common denominator. And now that we are multiplying, now we can cross simplify. 4 goes into 12 3 times. 6 goes into 12 2 times. 10 times 12 is 120. Now it's just down to a two-step equation, which we all know how to solve. Subtract your 10 on both sides. 3x equals 110. Divide by 3. Does 3 go into 110? No. So we leave it just like this. Right? Big difference when we simplify versus when we solve, right? Big difference. Asking for two completely different things. All right, are we ready to bring it to Algebra 2? Well, this is still sort of Algebra 1 if I'm being honest. So my directions are to simplify. Okay, we are not solving, we are simplifying. Do we agree that they have a common denominator? Yes, because they have a common denominator, our rule says keep our denominator and add our numerator. So we're going to have n squared minus 6n plus 4n minus 24. But I noticed that the negative 6n and the positive 4n are like terms. So we can add those. So we are n squared minus 2n minus 24 all over n squared plus 8n plus 16. But because our answer is a fraction, what must we do to all fractions? So reduce them, simplify, right? Well, right now, I don't know if I can reduce them until I do what to them? What should I do to the numerator and denominator? Factor, you got it. So now we're going to factor. So we are n minus 6 and an n plus 4. And in the denominator, we are an n plus 4 and another n plus 4. The n plus 4s will cancel. So we are down to an n minus 6 over an n plus 4. Can I do this? Good. We cannot cancel out those n's. They are now binomials. They are linked to other things, so they stay put. Okay, so for this one, we do not have a common denominator. So we're going to have to create a common denominator. When you have common denominators with, when you have denominators with variables, my recommendation for you is to factor first. Factor, then create a common denominator out of the factors. What do I mean? So in the first fraction, I can pull out a GCF of 5, and then I'm left with an x plus 2. In the second fraction, I can pull out a GCF of 3, and then I'm left with an x plus 2. So this is really nice because we have one common factor. What's the one common factor? The x plus 2. But now this is a 5, this is a 3. So I still need to make a common factor between 5 and 3. We'll make it 15. So our new common denominator is going to be 15 times the quantity of x plus 2. Now to make the first fraction have that denominator 15 times the quantity of x plus 2, well, I have a 5 and I have the quantity of x plus 2. So do you all agree all I have to do is multiply by 3? So I'm going to multiply bottom by 3 and top by 3. So in the numerator, I'm going to distribute in that 3. I'm going to get 12x plus 9. Now, in the second fraction, again, I need to make this denominator into 15 times the quantity of x plus 2. I already have the x plus 2 and I have a 3, so I need to multiply it by 5. And we're going to end up with 5x minus 35. All right, now we have a common denominator of 15 times the quantity of x plus 2. So now we can combine our numerator, which is 12x plus 9, but now be very, very careful. This is minus, right? It's not a plus sign, it's a minus. But I'm not just subtracting 5x. What am I subtracting? The whole quantity of 5x minus 35. So what do I need with the 5x minus 35? Parentheses. So this is minus the whole quantity of 5x minus 35. So now we distribute in. If you wanted to just distribute from the beginning, would that have been okay? Yeah, absolutely. This is going to bring us to 12x plus 9 minus 5x plus 35 all over 15 times the quantity of x plus 2. And now we simplify. 12x and negative 5x is a 7x. 9 plus 35 is 44, all over 15 times x plus 2. There's no GCF in that numerator, right? Do I have to distribute in that 15? No. If you wanted to, would it have been okay? It's fine. But why do something if you don't have to? Okay, do we all agree the common denominator is what we need to create? In order to create a common denominator, what did I tell you to do to all of the denominators if possible? Factor. So let's go through and factor. Okay, so the first fraction has a denominator of a plus 3, a minus 3. The second one has an a plus 3, and the third one has a 3 minus a. Any way I can change that 3 minus a into an a minus 3? Yeah,
Multiply by negative.
You got it. We're going to multiply by a negative. Where do I like to assign the negative? Anybody remember? Where do I like to assign the negative? Yeah, I like to assign it to the numerator, so I'm going to assign that. I'm going to make it a -2. And then when I make that a -2, this becomes an a minus 3. Okay, so now we must choose a common denominator. I think we all agree our common denominator will be an a plus 3 and an a minus 3. For the first fraction, anything I need to multiply? No, because we already have that common denominator, so that just stays 5a. In the second fraction, I have an a plus 3, but I need to multiply by the quantity of a minus 3. Are you all okay if I distribute in right away? So this is going to be a 4a minus 12. And in the last fraction, I have an a minus 3, and I need an a plus 3. And once again, I'm going to distribute in right away. So this is a -2a minus 6. And now that we have a common denominator, now I can simplify my numerator, and I'm going to do it right away. So I have a 5a, oh, sorry, you know what? Nope, because of that minus, so we don't get confused, I'm going to write it out in the numerator. So we have 5a minus, because I'm subtracting that whole quantity of 4a minus 12, what am I going to put? Parentheses, plus -2a minus 6. So now I'm going to distribute in that negative. So we are 5a minus 4a plus 12 minus 2a minus 6 all over a plus 3 times a minus 3. Okay, so now we combine our like terms. 5a minus 4a is 1a. 1a minus 2a is a -a. And then we are going to have 12 minus 6 is +6. There is nothing else to do. If you want to pull out a negative on the top to make it a minus 6, like negative times the quantity of a minus 6, you can, but it really doesn't matter. You can leave it just like this. All right. Okay, so we're going to make a common denominator. In order to create a common denominator, we are going to factor our denominators. Is there anything I can factor with the y to the n plus 6? Anything I can do there? No, it is what it is. It's y to the n plus 6. Nothing I can do there. All right, what about y to the 2n plus 6y to the n? What could I do there? I can pull out a GCF of y to the n. And when I pull out a GCF of y to the n, I'm left with y to the n plus 6, which is nice because we have one similar factor. We have the y to the n plus 6 and another y to the n plus 6. So my common denominator will be y to the n times the quantity of y to the n plus 6. So for the first fraction, I'm going to just multiply by y to the n. So in my numerator, I have y to the 2n. Anything to do with the second fraction? No, we already have that denominator, so we are good to go. We're just going to bring down 6 minus 5y to the n.
How is it 2n?
Oh, because when you're multiplying, right, if you have, let's say, x to the third times x to the fourth, you keep your base and you add the exponents, right?
But aren't you squaring it?
We're not squaring it.
It's y to the n times y to the n.
Yeah, you're multiplying it, right? Y to the n times y to the n. You keep your base and you add your exponents. 1n plus 1n is 2n. Or if you were looking at it as y to the n raised to the second power, then you multiply the exponents, which is still y to the 2n. So no matter what, it's y to the 2n. You're welcome. Okay, so now we have our common denominator. And I'm going to have y to the 2n. Are you guys okay if I just distribute that negative right away? Everybody okay with that? All right, so we will have a negative 6 plus a positive 5y to the n. Focus in on this numerator. What am I going to tell you? What am I going to tell you about that numerator? Something besides Angie. I can tell you. Adam? Yeah, we can factor this. If I have y to the 2n, I'm going to rewrite it, plus 5y to the n minus 6. Right? We have the same variable base, and isn't one exponent double the other? That means we can factor this. Can somebody factor that numerator for me? Tell me what you get. Sean? Plus 6, you got it. So once we factored, we are now able to cancel out those y to the quantities of y to the n plus 6. If I didn't factor, would this have been completely correct? No, because we can simplify it. So now we are left with y to the n minus 1 over y to the n. Can I cancel out those y to the n's? No. We're done here. All right, last problem for today. Then I will give you back your tests. What do we have? Difference of cubes. Good job. We have difference of cubes. So this is going to be x minus y, and then x squared plus xy plus y squared. Some of you were messing up difference of cubes on your test. You need to know it there. It's not going anywhere. Okay, so do we all agree our common denominator will be x minus y times the quantity of x squared plus xy plus y squared? So in the first fraction, we will multiply by the quantity of x squared plus xy plus y squared. And I'm going to distribute in that 2 right away. So we are going to have 2x squared plus 2xy plus 2y squared. And the other numerator stays the same because we already had that denominator. All right, now we combine our like terms. So we're going to have a negative, oh, I guess it doesn't matter which one you put first, so I'll put the positive. So we're going to have 2x squared plus 4xy, I'm just adding my numerators, plus 2y minus 4y squared. Was there supposed to be a squared here? This is supposed to be squared, wasn't it? All right, so that's a 2y squared minus 4y squared, which gives us negative 2y squared. Sorry about that. All over x minus y times the quantity of x squared plus xy plus y squared. So you can pull out a GCF of 2. Not going to really help. But we're x squared plus 2xy minus y squared. Can I factor x squared plus 2xy minus y squared? Can I factor that? No. There's no factors of -1 that will add to a +2. There's no factors of -1 that will add to a +2. So can I factor this? No. So can anything simplify? No. If you realize that from this step up here, did you need to pull out the 2? No. Okay, we are done.